Welcome to Brain Vision.
So this question is asking us about the concept of shielding. So when we talk about shielding, the meaning is just, the same thing as the lexical meaning, which means to protect or shield something, you're covering something. So the same thing also applies in the atomic level. And in this case, we have the shielding done by the electrons in the shell. So how do we describe this? If you remember the basic description of an atom has the nucleus containing proton and neutron. And like we know that the proton is positively charged and the neutron is has a charge of 0. So the net charge on the nucleus is positive, right? So you have the nucleus that is positively charged. Draw this way. You have a nucleus that is positively charged, and then you have shells of electron surrounding it. So let's assume that this particular atom has 4 shells, shell number 1, 2, and 3. So this innermost shell, 1 and 2, they are called the core shell. 1 and 2 are called the core shell. And shell number 3 is called the valence shell. So the core shell are the one in between, or the inner shell, and the valence shell is the last shell. So what happened? The core shell shield the electron in the valence shell. And when we talk about shielding, it's shielding the effective nuclear charge, which is positive, from being experienced by the electron in the third shell. Likewise, the electrons in the first shell are shielding the electrons in the second shell. Okay, it's just like how do I describe this? How do I explain that? You have a hot stone. The stone is very hot, and when something is hot, it radiates heat. So to prevent the heat from being radiated, you cover the stone with a ceramic bowl of maybe a particular thickness and size. And to further prevent the heat from emanating, maybe you feel now the ceramic bowl is getting warmer, then you cover it with a bigger and thicker ceramic bowl. So you're just preventing the heat from spreading. So just exactly the same thing is happening here. You have a nucleus with positive charge. So the positive charge is producing an effective nuclear charge whose function is just to attract the negatively charged electron in the shell to itself. So this first shell is shielding the electrons in the second shell from feeling the impact of this positive charge from the nucleus. And then the second shell and the first shell are shielding the electrons in the third shell from feeling the impact of the positive charge from the nucleus. So the core electron basically shields more. It does the more shielding, and mathematically you can calculate the effective nuclear charge that is felt by an electron in a particular shell or orbiter using the screening constant. And from experience, I think the screening constant for electron in the first shell is like 1.0. For that from the second shell is like I think it's like 0.5, 0.85, and so on and so forth. So you observe that as you go out further from the nucleus, the squaring constant is decreasing. And likewise, the same way, the effective nuclear charge also decreases with the distance you travel away from the nucleus. So the core shell shows more. Core shell, or the core electron, I would rather say, the core electron, the core electron, core electron shields more. And do not forget, the core electron are contained in the core shell, and valence electron are contained in the valence shell.